Hi, today what we are going to discuss is one of the last portion of your statistics syllabus, correlation. So far we have covered almost the entire portion of your syllabus, starting from the basic descriptive statistics to the advanced inferential statistics called non-parametric test. Okay, so in between these classes we missed one class, that's correlations. Okay, and correlation, as you know, is one of the very simple idea in statistics, but it is most widely used in almost all the branches of science, especially in research. Okay, and so far our discussion was confined to only the univariate distribution, or we deal with a distribution with only one variable. Okay, now in correlation what we are going to measure is what is the strength of the association, or what is the strength of the relationship between two or more variables, or how two or more variables are related each other. Okay, so there must be two variables. Okay, so now in correlation we are always deals with bivariate distribution or a multivariate distribution where there will be more than two variables. Okay, yes. So in this correlation what we are going to tell is, okay, how we can find out whether two variables are related or associated or not. Okay, then you might have learned the idea of correlation in your degree level or in your PG levels. Okay, so I'm just going to brush up your previous knowledge, and I'm not going to teach you the new thing. And because nothing is there in the correlation, the new thing is not there in the correlation. Okay, so correlation typically measure three ideas or three aspects of a relationship. A relationship will have many different aspects. Among such aspects, only three aspects will be discussed in the correlation. A correlation will only analyze three aspects of a relationship. First one is, what is the direction of the relationship? Okay, what is the direction of a relationship? What is the form of a relationship? What is the degree of a relationship? Direction means what? Whether it is positively related or negatively related or not. What is the form? Form is nothing but whether this association is linear or non-linear. Okay, what's the degree of relationship? Whether there is a high degree, or whether these two variables are highly related or least related or low related. Okay, yes. Then I'm not going to discuss the example, because you know that if there are two variables and if there is theoretically these two variables are related, then we can find out how that two variable, how much or to what extent these variables are related. Okay, for example, children's IQ and parents IQ. The biologically, the research shows that the children IQ and their parents IQ are related, positively related. Okay, we can check it using the data. Okay, the number of police patrol and the number of crime. Okay, as the police record says that as the number of patrol by police is increasing, then there is likely to decrease the chance for criminal activities. Okay, then stage performance and practice. Okay, how these are related. Okay, so stage performance and practice. If we practice more, then the performance will be better. Okay, then attendance in the class and the class performance. Those who are attending more classes, their mark will be likely to increase. Okay, so in all these variables, or in all these two variables, there may be a theoretical relations. Okay, then that we can analyze using the method called correlation. Okay, yes. Then Coming to the direction of a relationship, as I told you that the direction means what? Whether there is a positive association or a negative association between these two variables. Okay, then if two variables are moving in the same directions, or if they are tend to change in the same directions, as one increases the other one is also increases. If one variable is increasing, the other variable is also increasing, then there is a positive correlation. And if one variable is decreasing, the other variable is also decreasing, then also there is a positive association. Okay, whereas if two variables are tend to move in opposite direction, if one increase, other is decreasing, okay, whereas one decreasing, other is increasing, then the correlation is said to be negative. Okay, then as you can see the examples in the tables, quantity demand for a commodity and its price, as you know, it is negatively related. Okay, then quantity supplied and price, it is positively related. Okay, then coming to the form of associationship, there are two different forms. Okay, linear and non-linear. Okay, then what is the linear association? The change in one variable leads to a constant ratio of changes in other variables. How one variable is moving, the same way the other variable is also moving. Okay, look at the first table. When x was 2, y was 5. When x moves to 4, there is a double change. There's a double fold increase. Okay, then y is also increased, or y also increased the same constant ratio, 5 to 10. Okay, then 4 to 6, 10 to 15. Okay, so x is increasing by 2, whereas this y is increasing by 5. Okay, but the rate of changes is in a constant ratio. Okay, if the movement is in such a manner, then we can say that these two variables are linearly associated or linearly related. Okay, then let me tell you one thing. The correlation will tell us, a correlation will analyze only the linear associationship. Okay, so all the method that we are going to discuss in this class will deal with only linear associationship. Okay, it won't tell us whether there is a non-linear relationship or not. Okay, yes. Then coming to the non-linear relationship, what's non-linear? The changes in one variable is not in a constant ratio of changes in other variables. Okay, both variables are changing, but in different ratios. Okay, then if we are having this kind of a relationship, then if we plot this relationship, then we will get a curvilinear. Okay, we will get a curvilinear or U-shaped or reverse U-shaped or inverted U-shapes. Such kind of curve we will get. Okay, whereas if we draw a graph for a linear associationship, we will get a straight line. Okay, so let me repeat one thing. The correlation analysis will deal with only linear associationship, not the curvilinear associationship. Okay, then coming to the different types of correlations, on the basis of the number of variables included in our correlation analysis, we can classify the correlation into simple, partial, or simple, multiple, and partial. Simple means what? Correlation between two variables, simple correlations, or two variable correlations. Okay, then correlation between more than two variables, multiple correlation. Okay, whereas if we are dealing with more than two variables but keeping all other variables except two as constant, then we are having a partial correlation. Okay, so partial correlation is the one type of a multiple correlation, but we are allowed to change only two variable, but and keeping all other variable as constant. Okay, yes. Suppose if we are dealing with only the relation between QD and P, quantity demanded for a commodity and its price, we are having only two variable, we are finding out the direction of the relationship, then we are having a simple correlation. Okay, whereas If we are finding the correlation between quantity demand for a commodity, its price, income, then income of the related commodity, sorry, price for the related commodity, then we are having a multiple correlation. Okay. Then if we are studying the correlation between quantity demanded for a commodity, its price, income of the consumer, price of that commodity, but we are allowed to change only QD and P, income of the consumer is constant and the related commodity price is constant, then we are having a partial correlations. Okay? Yes. Now, coming to the how to measure the correlation. How to measure the correlations. Okay? Then come to the degree. Now we have discussed direction, then we discussed the form of a correlation. Now we are coming to the degree of a correlation. Okay, so how we can measure the degree of a correlations? How we can find out whether the to what extent the two variables are related? Okay, for that we can use certain correlation measures. Okay, so broadly the correlation measures can be categorized into the graphical method and the algebraic method or mathematical method. Okay, then the graphical method is the scatter diagram and correlation graph is the two different methods, two different graphic method. From that we can find out the direction of a relationship. Okay, then in mathematical method, the mathematical methods are, there are two different types of mathematical methods. Okay, and these two methods are based on what type of data you are using or what is your scale of the measurement. Okay, if your data is in ratio scale or interval scale, then we can go for Karl Pearson correlation method or we can go for OLS method. Okay, then if your data is in ordinal scale, then you can go for Spearman rank correlation method. Okay, so coming to the scatter diagram. So scatter diagram is nothing but a diagram of dots. Okay, we are connecting certain dots. Okay, so it's a diagram of dots obtained by plotting the values of x and y on vertical and horizontal axis. Okay, so here we are having two variables. One variable is expressed or drawn in horizontal axis, one in vertical axis. Then its joint values are obtained by dots. Okay, then such a diagram or such a graph is known as scatter diagram or a scatter graph. Okay, so you can look at this graph. Okay, in the first case, look at the case of A. All diagrams are on a straight line. Okay, from positive to negatives. Okay, so we can say that there is a negative correlations. Okay, look at the C. In C, it is not a straight line, but we can derive a positive correlation because all these dots are moving in a positive directions, but not in a straight line manner. Okay, but in the case of B, you cannot observe any kind of correlation because all these dots are scattered around the graph. Okay, and we cannot observe any kind of correlation. And in last one, D, you can say that even though it is scattered around the graph, but on a large scale, when we look at the graph, you can see that it is negatively correlated. Okay, so in the first case, we can say that there will be a perfect negative correlations. Okay, in the case of B, we can say that the correlation is very low or correlation is zero. In the case of C, we can say that the correlation is positive, but it is not perfect to 1. Okay, less than 1. Okay, in the case of D, you can say that there is a very low negative correlation. Okay, yes. Then coming to the correlation graph. Okay, so in correlation graph, in scatter diagram, we have got only one dots for one x and y. We have two variable y and x. but we are getting only one dots for one x and one y. But in correlation graph, okay, we are obtaining graph for graph for x and y separately. Okay, but for drawing such kind of a correlation graph, we need to have a time series data. Okay, so correlation graph can only drawn for a time series data. Okay, so if the values of two variable x and y's are plotted on a graph paper, we will get two different curves, one for x and one for y. Okay, and this curve shows the direction and closedness of the two curves, and this will tell us how well these two variables are related or not. Okay, if you look at the first graph, you can see that both variables are moving in different way, but in the same direction, to positive directions. Okay, both are increasing, even though the pace of the increase is different. But you look at the second graph, is one is increasing, the other is decreasing. Okay, so in the second case there is a negative correlation, but in the case of first there is a positive correlation. Okay, so this is all about the correlation graph. And coming to the mathematical method. Okay, so basically the correlation analysis is derived from the covariance analysis. Okay, you might have learned the covariance analysis. Okay, so covariance is nothing but it will tell us how two random variables move together, or how two random variables are moving. Okay, that's we will get from the covariance analysis. Okay, so correlation is an extension of this correlation is an extension of a covariance analysis. Okay, so in terms of covariance and variance, we can express or we can find out the correlations. Okay, so correlation is symbolized by R. It is covariance of x and y. If there are two variables x and y, you take the covariance of x and y divided by standard deviation of x and standard deviation of y. Okay, so this is the equation for finding out the correlations. Covariance of x and y divided by variance of x and standard deviation of x and standard deviation of y. Okay, then what is covariance? Covariance is nothing but sigma x minus x bar into y minus y bar. Okay, so first you find out x bar, then find out y bar, then you find out x minus x bar, then you find out y minus y bar, you multiply x minus x bar and y minus y bar, then you take the summation. That is the sigma x minus x bar into y minus y bar divided by total number of observations. That will give you the covariance. Okay, then what is the standard deviation? We already seen that sigma x minus x bar square divided by n under root. Then what is y? Standard deviation of y? Sigma y minus y bar square divided by n under root. Okay, so let me tell you one thing. The direction of a relationship is determined by the numerator. What's the numerator here? Covariance of x and y. Okay, so covariance of x and y is negative, then correlation will be negative. If the numerator is positive, then relationship is positive or direction is positive, because the denominator is standard deviation or variance. Okay, as you know that the variance or standard deviation will never go negatives. Okay, it can be 0. Okay, it can be positive values, but it will never go to 0. Sorry, never go to negative. That's why, okay, the denominator will not tell us anything about the direction of the relationship. It is only the numerator, covariance of y and x, will tell us what is the direction of a relationship. If covariance of y and x is positive, then the correlation will be also positive. If it is negative, then correlation will be negative. Okay, yes. Then second method is called Pearson method. Okay, So the Kalpius method of correlation, you may know that, and this can be find out using different equations. There are direct method, shortcut method, step deviation method. Okay, I'm not going for that things. Okay, I'm just introducing. I'm just giving you only one method called deviation method. Okay, because if you learn this method, then it will be very easy to learn the regression analysis. Okay, so what is this method is? In this method, correlation is sigma x into y. Sigma small x into small y. The same idea. Okay, what is this? What is small x? Sigma x minus x bar into y minus y bar. Okay, then divided by sigma small x square. It is standard deviation. Then sigma small y square. It is also a standard deviation of y. Okay, so both the first method and this method are same, but we are expressing this in terms of sigma x into y, but earlier we expressed in terms of covariance. Okay, that's the difference only. Okay, so here I am giving you an example. There are two variables y and x. Okay, we want to find out this how this y and x are related. What we have to do? You take the y values, find out the average. Okay, so we have got x bar is equal to, sorry, x bar is equal to, y bar is equal to 10. Take the x, find out the average, then x bar is equal to 9. There's a mistake in this. Okay, so y bar is 10 and x bar is 9. Okay, now what we have to do, you find out the small x and small y. What is small x means? Okay, then small x mean what? There's a mistake in the heading. Okay, you just take one first column as x and second column as y. Okay, then it will be okay. Then you find out small x, you find out small y. Small x means what? Actual x minus your x bar. Okay, so in the first case 12 is the x value, x bar is 10, 12 minus 10, it is equal to 2. Okay, then small x, small y, then small x square, then small y square, then small x into small y. Okay, so this is the method. Small x, small y, small x square, small y square, small x into small y. Okay, then now we have got entire thing. Small x into small y is equal to 46. Okay, small x square is equal to 28, small y square is equal to 84. Then put this value in the equation. 46 divided by root 28 into root 84. Okay, we have got around 0.94. Okay, so we know that the correlation value I will discuss later always lies between -1 and +1. Here our value is very close to 1, 0.94. Okay, so we have to say that this x and y's are highly correlated. X and y's are highly correlated. Okay, yes. Then coming to the certain properties of the correlation. Okay, so first property, correlation coefficient is a pure number and independent of the origin and scale. What does this say? Pure number means what? Whether your data is in kilogram, whether your data is in percentage, whether your data is in kilometer, no problem. Whatever may be your unit of measurement of your actual data, the correlation will be a pure number. You will get a number only. That number will lies in between -1 and +1. Okay, so whatever may be your measurement of your data or measurement of your variable, okay, your correlation will be measured only on a scale between -1 and +1. That's why we are saying that correlation is a pure number, independent of the origin. Okay, and what is the independent of the origin means what? There are two terms, independent of the origin and independent of the scale. I'll discuss you what is independent of the origin. Okay, independent of the origin means what? If you add a constant number to each values, your correlation will be independent. That means it will not change. Okay, what scales? If you multiply a constant number to a variable, or you divide a constant number to from this variable, from this data, the correlation result won't change. Look at this data, x and y. We are having x and y. We found the correlation is minus 3.7264. Okay, then you add plus 3 to both x and y, your result won't change. Result is still 0.372. Then you add 3 to x, then 2 to y, still your result won't change. Okay, then this is what is called independent of the origin. Okay, then independent of the scale of the measurement or independent of the scale. What is that? If you multiply a constant number to x and y both, x into 3, y into 3, the correlation is same. Then you multiply 3 to x and 2 to y, still your result won't change. Okay, this is what we call the correlation is independent of the origin and independent of the scale, and it is a pure number. Coming to the second one, the value of the correlation will be always lies in between minus 1 and plus 1. Okay, you won't get a value beyond minus 1 and beyond plus 1. Okay, then if your values are plus 1, there is a perfect positive correlation. If it is minus 1, there is a negative correlation, perfect negative correlation. Okay, if your value is 0, then there is no correlation. Okay, and in between these minus 1 and plus 1, there are large number of values are possible. Okay, and these variables you can categorize into very high degree, moderate degree, low degree, very low degree, depending upon the different range. Okay, and there is no clear-cut range for these correlations, and some people say that high correlation, low correlation, okay, or moderate correlation, and some people say that very high degree, moderate, low degree, very low degree, no correlation, perfect correlations. Okay, so this is just I am giving you some idea, and there is no clear-cut definition for what would be the range of these degrees. Okay, yes. Then correlation is symmetric. What this means that if you take x in the first, y the next, or y the first, x the second. Okay, if you change the variable x and y, if you change the position of the variable, okay, then the result will not change. Okay, that means for x and y we found the correlation, then we found the correlation between y and x, both will be the same. Okay, then the last one is not a property, but it is a statement associated with the correlation. The correlation always doesn't imply the causations. Correlation will not tell us whether there is a theoretically there is a relationship or not. Okay, that we will see, and that we will discuss later, or we will see. Yeah, I am discussing it. Okay, so what is this correlation and causation? Now, as I told you, correlation will not tell us whether there is a causation or not. Okay, so what is this causation and what is this correlation? Okay, so correlation is only one criteria for establishing a relationship. Okay, there are large number of different criteria for establishing a relationship, and correlation is only one among that. Okay, then before you suppose you are going to find out the correlation between class attendance and student performance. Okay, then you got a value 0.9. Okay, then you should not believe this 0.9. Okay, you just wait for some time. You have to look some other criterias. Okay, the first criteria is what? Whether it is a chance for coincidence. Sometimes the correlation may be happen due to coincidence. For example, suppose I am taking some students from Farooq College. I am just taking their class performance, and I am taking some marks from, I am taking some students attendance from some other college, MES college. So I have taken the mark from Farooq College, attendance from MES College. Then I found the correlation. I have got 0.9. What does it mean? Would you believe this correlation? What does it mean? If the attendance in MES College is very high, then the mark of the students in Farooq College will be very high. This is what we call the nonsense correlations. Okay, and how we have got the 0.9 correlations? This is what we call coincident. Okay, because both variables are moving in the same direction. That's why we are getting this coincidence. Okay, and in econometrics or in statistics, this kind of a correlation is known as nonsense or spurious correlations. Okay, that means theoretically there is no relationship between MES College attendance and Farooq College mark. Okay, then you take the if you take the IMR of Egypt or IMR of the Ethiopia, then you take the money supply of India, you just correlate it, you will get a correlation. Okay, that's why I'm saying you correlation is a pure number. Okay, and it is your duty to establish the correlation according to a theory. If the theory says there is a correlation, then you can say that these two variables are correlated. Okay, yes. And if there is no theoretical correlation, and if you find if in empirically there is a correlation, then it will be a spurious correlation. Okay, yes. Then influence of a third variable. Sometime if we find a correlation between two variables, a third variable or a mediator variable will be there. Okay, this mediator variable is determining the association. This mediator is establishing the correlations. Okay, for example, some students they are very regular in the class. Okay, but they are not getting that much mark. Then there is a third variables. And why these people are coming to the class? These people are coming to the class and this is not reflecting in their marks, because there is a third variable that is attracting them to this classes. It may be a teacher, okay, it may be a lover in the class. Okay, so these are all certain third variable. This third variable will establish a relationship. Okay, so when we discuss when we find out when we are going to estimate a correlation, we have to check whether there is a mediator variable or not. Okay, whether there is a mediator variable that will establish a correlations. Okay, and sometime the mutual influence may be possible. You just take the case of consumption, income, wealth. Consumption is depends on income and wealth. When your income increases, your wealth increases. If your wealth is very high, your income will be very high. Okay, so this income and wealth is a mutual variables. This mutual, there will be a mutual influence of this wealth and income on consumptions. Okay, but when we find the correlation between income and consumptions, there may be a mutual influence of wealth and income on consumption. So we will not get a clear picture of correlation between consumption and income. Okay, so these things we have to keep in mind when we do a correlation analysis. Okay, then after finding the correlation, okay, after finding the correlation, we have to check the reliability of this correlation coefficient. Okay, we cannot simply believe a correlation coefficient or correlation number. We have to go for checking the reliability of this correlation coefficient. Okay, then the probable error is a concept that is used to check the reliability of a correlation coefficient. Probable error. Okay. So what is the probable error is? The probable error is derived from the standard error. Okay, what is standard error? standard error of or a correlation is 1 minus r square divided by root n. This is what we call the standard error of a correlation coefficient. Okay, then probable error means what? If your standard error is multiplied by 0.6745, what is the 0.645? It is the normal distribution. Okay, in normal distribution 50% of the observation lies in the range of mu plus or minus 0.6745. Okay, so this 0.674% means the mid of these observations. It is derived from the normal distribution. Okay, so probable error is equal to 0.6745 into standard error of correlations. Okay, and the correlation coefficient will be always plus or minus, or correlation is plus or minus probable error of the R. Okay, it means that if we take a sample from the, suppose we have taken a sample from a population, we have got 0.9. Okay, then we have taken the same population, we have taken the other sample, we have got 0.1. There is a huge difference. Okay, and this huge difference should not be happened. Okay, and if you are taking the another sample from the same population, the correlation can be expected to vary only within this range. What is the range? R plus or minus PER. Okay, so R is allowed to change only plus or minus probable error. Okay, so for checking the reliability of for believing this probable error, there must be two conditions. First condition is the population should be normally distributed, and it should be taken, the sample should be taken using the simple or random sampling process. Okay, then if your correlation value is less than that of the PER, then you have to say that your correlation coefficient is not significant. Okay, or if your R is greater than your probable error, then you have to say that this value is, the correlation is significant. Okay, so the idea of the probable error is what? The probable error is used to measure the reliability of a correlation coefficient, whether we can reliable this correlation coefficient or not. Okay, it means that if we take the different sample from the same population, how it will vary. That's we are going to check in this probable error. Now, after getting the correlation coefficient, we have checked the reliability, and now we have to check whether we have to conduct a hypothesis testing. Okay. Okay, so after finding out the correlation, we have to do a hypothesis testing to confirm your correlations. Okay, so for that, what we have to do, we are having two different correlation coefficient for a population and correlation coefficient for a sample. Okay, but what we usually do, we are getting the idea of, we are finding the correlation for a sample. Okay, and usually we are not using the populations. Okay, yes, yeah. So what we do, we are having a sample correlation coefficient R and a population correlation coefficient rho. Okay, then we will do a hypothesis testing about the sample correlation, and we will infer what is the correlation in the population. Okay, that we are going to check, or that we are going to do in the hypothesis testing. Okay, so the procedure is simple as we have learned before. Okay, and then as you know that the first step is the null hypothesis test, or you state the null hypothesis and alternative hypothesis. Okay, and there are two different hypotheses. Okay, then first one is sorry, there are two different tests. If it is two-tailed test, then we have to specify the alternative hypothesis as not equal to. Okay, then if it is one-tailed test, it may be a negative test or positive test. Okay, so if it is negative, then we have to give greater than symbol, and if it is negative, we have to give a less than symbol. Okay, so in this way we can set a null hypothesis and alternative hypothesis. The second thing is select the distribution to use. What kind of distribution we will use to test the correlation coefficient? Okay, and one of the assumption of this correlation coefficient is, if we are having two different variable x and y, this both x and y should be come from a population that is normal distributed. Okay, then only we can believe this correlation coefficient. Okay, so since two distributions are normally distributed, okay, then we can use the t distribution, because most of the time we don't know about the populations and its standard deviations. Okay, so we are relying on the sample standard deviations, and the population is normal, then we can go for t test. Okay, and in some time we can use z test. If we know the population standard, then we can use the z test, no problem. Okay, but most of the time, the 99% we are using t test for finding the hypothesis, to conduct the hypothesis testing about the correlation coefficient. Okay, then after, what we have to do, we would determine the rejection and non-rejection region using the degrees of freedom. Okay, as you know that degrees of freedom is n minus 2 if it is two variable, n minus 3 if there is three variables. Okay, so n minus k is the your degrees of freedom, k is the number of variable in your analysis. Okay, then you calculate the t test. Okay, or test value for t, it is nothing but your r value minus rho divided by standard error. Okay, so it can be converted into r divided by root 1 minus r square divided by n minus 2. Okay, so this can be again convert into r into root n minus 2 divided by 1 minus r square. Okay, so the test value is nothing but r into n minus 2 root under divided by 1 minus r square. Okay, then you will get a corresponding value from the table value, t table value. You just compare actual t value and t table values. Okay, if your actual test value is greater than your table t value, then you reject the null hypothesis or you accept the null hypothesis. Okay, yes. And now we are coming to the rank correlation. Okay, so if two variables, the Karl-Pearson measure of correlation will be applicable only for quantitative data or ratio scale and interval scale. Okay, and sometimes the data may be in qualitative format. The qualitative data can be nominal scale and ordinal scales. Okay, this rank correlation is applicable only for ordinal scale data. If our data is a nominal scale, then we cannot find the correlations. Okay, yes. So there are certain qualitative attributes sometimes that we have to measure the correlation. Okay, for example, beauty, intelligence. Okay, so in all this case, what we have to do, we can number this beauty or intelligence, or we can rank them. Okay, so the rank correlation is applicable only to those data that can be ranked, or that can be ordered in ascending or descending. Okay, if there's a data that we cannot order or that we cannot rank, then this rank correlation is not applicable. Okay, and this method was developed by Charles Edward Spearman in 1904. Okay, it's very simple method, and the equation is rho is equal to 1 minus 6 into sigma d square divided by n into n square minus 1. Okay, first thing what we have to do, you have to arrange the data in ascending or you have to arrange the x in ascending or descending order. If you are doing ascending order, then the same order have to be continued in rank in the second variable. Okay, so y and x should be ranked according to ascending or descending order. Okay, then you find the difference between two ranks, that is called d. Okay, then you find out the d square. Okay, then you substitute this value in the equation. Okay, so here we are finding out the rank between maths and statistics, and we have got minus 0.418. There is a negative correlation between these two ranks. Okay, and similar to the Karl-Pearson coefficient of correlation, Spearman rank correlation is also lies in between -1 and +1. Okay, and basically in rank correlation is also the same methodologies of Karl-Pearson is applying, but the application is on the ranks. Okay, both are the same method. In rank correlation method, we are applying the methodology of Karl-Pearson into the ranks. Okay, and in Karl-Pearson method, there is an assumption. The assumption says that the sample should be drawn from a population, and that population should be normally distributed. Whereas in Spearman rank correlation method, there is no such kind of an assumptions, or it is a distribution free or a non-parametric method. Okay, so Spearman rank correlation method is a distribution free method or a non-parametric method. Okay, yes. Then coming to the coefficient of determination. Okay, so it is nothing but if you have find out the r. Okay, if you just square it, then it will give you what is the r square, or it will tell us the coefficient of determination. That we will see this later. Okay, when we discuss about the regression method, this will be discussed in detail. Okay, then just opposite of this r square, there is a concept called a coefficient of alienation or a coefficient of non-determination. It is nothing but 1 minus r square. Okay, yes. Then coming to the partial or semi-partial correlation. Okay, then partial correlation means what? It measures the linear correlation between two variables, okay, while controlling the effect of other variables. It will control some effects, and it will learn only the correlation between these two variables. Okay, then if you want to find out the correlation between x1 and x2, holding x3 as constant for both x1 and x2, okay, then this is what we call the partial correlation. Okay, in partial correlation, there are two variables x1 and x2, and one more variable is x3, and this x3 is keeping constant as for both x1 and x2. Okay, whereas if we are if we are keeping this constant differently for x1 and x2, then it is known as semi-partial correlation. Okay, and it's not that much important. Okay, then coming to the correlation matrix. Suppose if you are dealing with a multiple correlation, okay, then we will get a correlation matrix. You can just see in this slide. Okay, so here we are having 4 variable w, x, y, and z. Okay, then this correlation matrix will tell us how these 4 variables are intercorrelated with each other. Okay, so you see 1, okay, w1, what it means? Well, w correlation is 1, okay, and x and w correlation is also 1. Then y and w 0.92, y and z 0.97, and y and z is equal to 0.88. Okay, so this correlation matrix we will have only when we have a more than 2 variables, and this correlation matrix will measure the correlation between all the variables. Okay, correlation between all these variables. Then one more concept is there called autocorrelation. Okay, so the autocorrelation will measure the association between the values of the same variable but at different time period. Okay, so correlation within one variable but at different point of time, that will be measured by the autocorrelation. Okay, so the equation is given, it is not that much important. When we discuss about the econometric thing, then this thing we will discuss later. Okay, yes, so that's all about today's sessions. Okay, so in this session we have discussed what is correlations, what aspects of relationship that this correlation will be measured. Okay, then positive and negative correlation, linear and non-linear correlation, simple, multiple and partial correlation. Okay, then how to measure the correlation, scatter diagram, correlation graph, Spearman rank correlation method, its properties, then rank correlation method, when it is applicable. Okay, then we have discussed how to do hypothesis testing. Okay, so that's all about today's session. And if you have any doubts, and because this ഞാൻ വളരെ സ്പീഡിലാണ് പോയത്, കാരണം ഇതൊക്കെ നിങ്ങൾക്ക് അറിയുന്നതായതുകൊണ്ടാണ് സ്പീഡ് പോകാൻ കാരണം. ഓക്കെ, ആൻഡ് ഇഫ് യു ഹാവ് എനി ഡൗട്ട്സ് you can drop me a message or you can call me. Okay, yes, thank you.